3P Filtersystems presents the 3P Hydrosystem. This innovative system filters pollutants out of runoff from roads, parking areas and metal roofs. The final discharge is clean enough to re-enter the natural water cycle safely. For millions of years, water has been one of the most important elements on our planet, if not the most important of all. No ecosystem can exist without it, and yet our ecosystems suffer direct, long-term effects of damage to the water cycle. The water cycle is most at risk from industrialization and population growth. In addition, although the modern standard of living has its advantages, it also has its downsides too. Even as it accumulates in the atmosphere, our rainwater is affected by emissions from industry, heating, cars and aircraft. Once it has fallen, contamination continues as runoff from sealed surfaces like roofs, roads, car parks and even the metal roofing on historical buildings seeps into our groundwater. We are slowly but surely poisoning future generations. EU guidelines represent a first step in preventing the contamination of our water and making the protection of our waters our top priority. By 2015 there will be a complete ban on discharging any pollutants into our surface waters or our groundwater. Action at a local level will provide the most cost-efficient solutions. Some solutions have already been in use for years, but reliability issues and space requirements make them an unsuitable investment for urban environments. This filter system works by forcing contaminated water upwards through the filter elements. There are several cleaning stages. Firstly, the water is directed into the hydrodynamic separator. Here, dirt particles and debris are separated by gravity and sedimentation and are collected in a sediment trap. The process is sometimes known as the teacup effect. As the incoming flow of rainwater builds up, the only way it can escape is by flowing upwards via the filter elements at the top of the tank. Here, cleaning takes place in 3 stages. The process of filtration removes all particles bigger than 0.4 mm from the water. Up to 98% of all filterable solids are removed at this stage. Any particles of heavy metals such as copper, zinc and cadmium are removed by adsorption. This is a chemical reaction. The third cleaning stage, taking place in the filter substrates, is precipitation. This makes molecules insoluble or virtually insoluble. They are then adsorbed or they settle. This process binds particles such as phosphates. With 3P substrates, there is no risk of adsorbed substances being redissolved by runoff from salted roads. Normal concentrations of hydrocarbons in contaminated water are held back by the filter media substrates. The floatable or oil retention assembly at the outlet of the filter holds back any higher concentrations of oil or other floatables that might accumulate in exceptional cases, for example after a road accident. After passing through the filter, the water is clean and can be safely returned to the natural water cycle. Dr. Carsten Dirkes from the H2O research explains with the help of a biotope in Hamburg-Harburg.
We are now in the pond area of the Eisendorfer Forst. Right behind me it's the B75. It's one of the main roads in Hamburg with a very high traffic density. Especially a lot of heavy trucks are using this street. So the runoff from this street contains a lot of harmful substances like heavy metals and hydrocarbons. That's why the city installed here a decentralized stormwater filtration unit containing of 2 Hydrosystems DN1000 that clean the water from the hydrocarbons and the heavy metals before it is discharged into these ponds.
This project is the work of the Office for Nature Conservation in the borough offices of Hamburg-Harburg. It was launched when some rare species of amphibian needed protection. Several filters had already been tested at this site, but this one delivered the most promising results. In the first year of the trial, water sampling was undertaken every month or after every rain shower. The samples were taken from this inlet distribution shaft and analyzed to see what they were carrying. The main compounds were copper, zinc, lead, hydrocarbons, phosphate, ammonia and solids. Samples were also taken at the same time from the outlet area of the filter. These showed very positive results even though the filters are connected to an area more than double than they should be. The system is about 95% effective TSS. For copper it is about 80% effective, 98% for ammonium and 82% for hydrocarbons. One look at the water will confirm these positive results. Our ecosystems are very sensitive, and if we want to preserve them for future generations, we need to protect them. Not only do we have to protect our waters, we also have to take care of our groundwater and consequently of our drinking water. The approach taken by the EU guidelines is constructive, and this filter system can be an important help in implementing them.